Alrighty, we are in the second part of Unit 5. Last time, we looked at where equations came from and we talked about the idea of equivalence, making sure that the left and right sides of an equation are equal to each other. This time we're going to build on that and actually solve equations. We're only looking at one steps today, so it shouldn't be too bad and we'll take it one step at a time. Alright, so before we dive into the details, we got to remember some stuff. We got to remember our opposite operations. So for example, the opposite of plus is going to be minus. The opposite of minus, well, that's going to be plus. Opposite of multiply is going to be divide, and I'm going to use a slash to represent divide. And then the opposite of divide is going to be multiply. I'm using a dot like that to represent multiply. The other thing I want to remember is how equivalency works. I want the thing on the left and on the right to be the same. Therefore, they're equivalent. As long as I do the same operations to both sides of an equal sign, it'll stay equivalent. So, for example, I might just randomly do plus 2 and plus 2 to both sides. Since I did the same thing, that'll be 6, and this will be 6. It's still equivalent. Remember, I always do the same work underneath each number. So, in the last notes, we did the following work. Let's say, for example, I wanted to add 4 here, and I wanted to add 4 here. I wound up with 8 on my right. I still need my equal sign, but since I couldn't add x plus 4, I ended up with x plus 4 equals 8. That's a one-step equation we've got. By doing the same operation to both sides, we got the equivalent equation, x plus 4 equals 8. From the much simpler equation, x equals 4. But can we work backwards? Can we get from x equals 4 to x plus 4 equals 8? Of course we can. All we have to do is unwind the equation by doing the opposite operations. We're going to take our more complex equation and unwind it by doing opposite operations. We're literally going backwards in time. So, instead of adding 4 to get up to this plus 4, we're going to subtract 4 to get back down to the original equation. So I'm going to subtract 4 from my right. And I'm going to do the exact same thing to my right side. Excuse me, I'm going to do that to my left and then do the same thing to my right. So when I do x plus 4 and then I subtract 4 as well, these are going to cancel out and I just end up with x on my left. On my right, I have 8 minus 4 and that goes back down to 4. Since we're doing the same thing to both sides, the equation remains equivalent. Okay, so last time we took a simple x equals and turned it into a more complex equation. Now we're taking a complex equation and unwinding it back into an x equals. It's just one step. So we do the same thing with all 4 operations. Just do the opposite of what you see. Looking at this example here, x minus 2 equals 2, someone took an original equation and then subtracted 2 from both sides. I know that because I see a minus 2. I can unwind this equation by doing the opposite of what I see here. I see a minus 2, so I'm going to do the opposite. Add 2 to both sides. Okay? Well, this minus 2 and this plus 2 cancel each other out. That just leaves an x on my left. On my right, I have 2 plus 2, and that gives me 4. Excuse me. That gives me 4. Let's keep going. For x plus 5 equals 7, I had an original equation, and I added 5 to both sides. I want to cancel out that adding 5 by subtracting 5. This plus 5 minus 5 cancel out, and I end up with x equals 7 minus 5 is 2. Continuing on, someone multiplied both sides here by 4, and I want to cancel that out by dividing both sides by 4. I'm doing a fraction bar, divide by 4, divide by 4. The 4's cancel out, I'm left with my x here, and then 12 divided by 4 is going to be 3. As one final example, someone divided both sides of this equation by 5. Now, the opposite of division is going to be multiplication, so on my left I'm going to multiply by 5, and on my right I'm also going to multiply by 5. Divide by 5, multiply by 5, cancel each other out. leaving myself with just an x. And then on my right, I'm going to multiply by 5. 2 times 5 is 10. So again, whether I have subtraction, addition, multiplication, or division, I'm just going to do the opposite of whatever I see. When I see subtraction, I'm going to add. When I see addition, I'm going to subtract. When I see multiplication, I'm going to divide. When I see division, I'm going to multiply. Do the opposite operation of what you see. Now, before you go to the back, I want you to try these checking understanding questions. Pause, see if you can complete them, and then we're going to flip to the other side. All right, let's flip to the back. Okay, so on the front of these notes, we solved for x. Awesome job! You've got the gist of the most important concept in algebra. Everything else is just details on top. But there's a trick to make sure your answers are never wrong. All you do is replace your x equals, or your answer, back into the complex equation, or your question. If the equivalency holds, that means you have the right answer. Remember, both equations should still be equivalent. So, let's try it. This is my x equals here. I know that x equals 4. If I replace this 4 back into x, my equivalency should still hold. And if you look, it probably should. I have 4, and I do 4 plus 4, and obviously that's 8. Since 8 plus 8 is equivalent, that means I did the right work. X does really equal 4. The equivalence on both sides still holds. As long as you did your work right, when you plug in the correct x equals answer, your left and right sides will still equal each other. If you do this, you will always know if you have the correct answer. If both sides are equal, you have the correct answer. So let's look at the questions we solved on the front. This time we're going to prove we're right by plugging in our answers. So I'm going to replace this x with 4 minus 2 equals 2. 4 minus 2 is 2. 2 equals 2. We're correct. Here, I've got x equals 2. So I do 2 plus 5. Can't forget my parentheses. Equals 7. 2 plus 5 is 7. And 7 equals 7. So everything is good. Continuing here, I'm going to replace my x with 3. 4 times 3 equals 12. 12 equals 12. Equivalent. We're correct. Finally, I know that x equals 10, so I'm going to replace x with 10. And wouldn't you know it, 10 divided by 5 is in fact 2. I'm still equivalent. That's all there is to it. By plugging your answer back into the question, you will always be able to make sure you have the right answer. And there's a helpful trick to this as well. Some questions are easiest to solve by just plugging in the answer. I want you to try that in the checking understanding. As always, let me know if you have any questions, and I'm happy to help you. If you felt like you got everything down, you can go ahead and try your formative. If not, I encourage you to do some practice. Thank you very much, and have a great day.